Hello everyone. In today's class, we'll be treating change of states of matter and then the vapor, solids, and liquids. Now, there is this thing called matter, and there are certain characteristics that matter has, and two major ones is that they occupy space. And then they have what? They have mass. And this matter tend to occur in different states. Now, three major states that we have, although we have others like ionized states and all, that has to do with plasma states, that has to do with charged gaseous ion. The three major ones that we have now is solid, liquid, and gases. Now, each of these states of matter possess their own innate energy. And as we said before, that when we're talking about energy, that we have kinetic energy, have potential energy. Now, we have chemical potential energy as well. That's like the energy due to the properties of that particular substance. So, the state of the matter, whether it's gaseous or whether it's gaseous and solid or liquid, is determined significantly by the potential energy, whether chemical potential energy or the normal potential energy of the substance. If the substance is not on the ground level, is on an elevated level, or the kinetic energy of the molecules that make up that particular substance. Now, so as I was saying, that for matter can be defined as the material substance that constitutes the observable universe. Basically, matter is basically what we can see, what we can touch, what occupies space, and then what actually has mass. Now, and these matters are made up of what? Atoms. The atoms, which are made up of protons, neutrons, and electrons, are the building blocks of all matters. Now, chemical energy is a type of potential energy that holds atoms and molecules together. So, in a matter, let's say for a block of wood, or whatever solid material that you have in front of you. Now, this particular substance, this particular wood or whatever, is made up of smaller substances, smaller particles, which we refer to as atoms. Now, these smaller particles, they can't form a solid unless they are held together by a particular force. So the force that is holding those particular substances together constitutes the chemical energy of that particular substance, and the chemical energy of that particular substance constitutes the potential energy. Chemical energy is usually due to potential energy, because potential is more like innate energy, and so that's where that comes from. And don't forget also that matter is one of anything that has mass and then you can take up space. It has volume. That's like the major characteristics of anything that is called matter. And then the state of matter, as I said before, that we have plasma also, but then you have three main ones: solid, liquid, and gases. But here they include plasma. But then we'll talk about plasma as well too. So now, looking at this diagram, you have your solid, you have your liquid, you have your gas. What can you observe? What can you see about these three states? The first is that for the solid, they are more like tightly packed. For liquid, they are less tightly packed. And then for the gases, they are not tightly packed. Now, the tightly packedness should tell you something about what is holding them together. That means for the solid, the forces holding them together is very, very strong and very, very significant. While for the liquid, the forces holding them together is strong, but is not as strong as that of the solid. While for the gas, the force holding them together is negligible, like it's really, really insignificant. And what else can you see about the solid? It's like their volume is definite. They have a definite volume. While the liquid, they don't have a definite volume, but then they take out the volume of the container that they find them in. And then gas, they don't have shape, they don't have volume. They don't. Gas don't have shape, but then they have volume. But then the only way you can like measure their volume is when you put them in the cylinder, and then they take up the. You can't even necessarily even measure their volume per se, because in that cylinder they are very spacious. So most of the volume that you think that you are measuring is really not their volume. It's just basically empty spaces. Okay, now the states within the device are in gaseous, liquid, and solid states. Now solids are distinguished by tight atomic bonds and a high viscosity, resulting in a rigid form. Most solids are crystalline in as such as they have a three-dimensional periodic atomic structure. Now certain solids lack the crystalline arrangement, so they are referred to as non-crystalline or amorphous. So that means they don't have something. For example, now like powder, you notice that it's not really as rigid as, let's say, a log of wood or something. And take note also that the forces, as I said before, that one of the major stuff that distinguish all these three states is the forces holding them together. Now, for a liquid is almost incompressible. Yes, it's incompressible compared to a gas. A gas is more compressible because of a lot of spaces between the molecules, so you can compress them, so you reduce the space between them. Whereas for solid, there is not much space between them, just that they can more like move over one another, but then there is no space between them. They can just like slide or glide over one another. So a liquid is an almost incompressible fluid that conforms to the shape of its container but retains a constant volume independent of the pressure. So the volume of a liquid is defined if the temperature and pressure are as constant. Now the volume of any of those three states is defined if the temperature and pressure are constant. It's not just restricted to liquid alone. That's why we still talk about gas laws for gases. Now, as the solid is heated past its melting point, it becomes liquid. So it's possible for it to change the state of the change from solid to liquid to gaseous state, depending on the substance that you are dealing with, that you have, and each of them have different points in which they are going to change to all those different states. Like for water now, when water wants to change from solid to liquid is at 0 degrees Celsius, while when it wants to change from liquid to gaseous, it's at 100 degrees Celsius. So the same, you have a lot of those turning point or those changing points for different substances. Now within the gas, the molecules of the gas have more kinetic energy because they are more the force of attraction between them is low. They are very well spaced, and their intermolecular force is like very, very small. So their molecules have more energy to actually move around compared to that of solid, that their molecules don't move around, they only vibrate about a point. Okay, now let's talk about some of the characteristics basically of all the three states before we then go back to the changing of states. So for solid now, as I said before, they have strong intermolecular forces, and then they basically just oscillate about a mean position. They can move from one point to another. Now, solids can be defined as a state of matter which has a definite shape and volume and has rigid structure. An example of that is iron. And solid possess the least compressibility and thermal expansion. So they can really expand no matter how much you actually heat them up. They can expand as much. And you can't really compress them much too because they are already tightly packed together. Now for liquid, they have weaker intermolecular forces, and there is much spacing between the molecules of liquid so that they are able to move over one another. They are able to flow over one another, and liquids can easily acquire the shape of a vessel, and then they have a fixed volume. Now, to convert from solid to liquid, you have to increase the temperature of that particular solid until it gets to a particular point, which we call melting point, that is going to change from that solid to liquid. Now, generally, the density of liquid lies between the density of solid and gases. Now, compressibility and thermal expansion of liquid are slightly higher than that of solid. What this means is that when you heat a liquid, there is a probability that it will expand, and when you it's like the probability of it expanding is like very, very high. While when you compress it, it's very likely for you to totally compress compared to that of solid, that you can't really compress it per se. An example of liquid is what is water, liquid water. Now let's talk about gases now. Now in gaseous state, there is a huge gap, huge distance, intermolecular distance between the molecules, and then the intermolecular force experienced between them is what negligible, as I said before. Now these molecules, now they're able to like undergo translational, rotational, vibrational motion, and the motion of those gas molecules are usually haphazard. They don't follow a certain pattern. They can just be going anyhow. Now they also do not have any fixed shape or volume. They just possess the volume of the container that they are in, and then they don't even possess the volume of the container they are in, because there are still like huge gap between them, so you can't really use that to actually quantify that volume. Now they possess the greatest compressibility and thermal expansion. That means when you heat them small like this, they can expand significantly, or when you try to compress them, they can still be compressed, like significantly compressed to the remaining two, the liquid and solid. So that's that for the state of matter. Now let's talk about the change of state of matter. Now, as I said before, an example of a substance that can undergo all the three states of matter is water. The water can become ice, solid. It can become like normal liquid water, and then it can become gaseous water, vapor. And this chart here just shows the conversion from solid to liquid, from liquid to gas. Now let's answer this question. Change of state, basically. Let me just define that. A change of state is like the conversion from one state of matter to another. That's really what change of state means. I don't think it will be asked, but then it's very important for you to actually understand what it means, so that in case you are asked any question about it, you'll be able to at least have an idea of, you'll be able to like link all these things together when we start talking about what actually causes those change. Now, why do phase changes occur? Now, when temperature or pressure change of a system occurs, phase changes occur. So that means there are two ways in which we can change the state of the matter: by changing the temperature, or by changing the volume, or by changing the pressure. Now, when the temperature or the pressure increases, the interaction between the molecules increases. Similarly, when the temperature decreases, the molecules and atoms, they settle into a more rigid structure. Now, what that means is if you increase the temperature, now temperature is a function of the kinetic energy of the molecule. So you increasing the temperature is like you are increasing the kinetic energy of the molecules, and when you increase the kinetic energy of the molecules, they tend to like collide with one another. They tend to like possess more kinetic energy, and that will cause them to be able to like break bonds between themselves, and then they'll be able to like move far apart from one another. So that means that, and don't forget that we said solid is more compact, while gases are less compact, they are more spaced. So now we are saying that okay, you are increasing temperature. When you increase the temperature, the molecules are gaining more kinetic energy, and then they are moving far apart. So that means to change the state from solid to liquid to gas, you have to increase the temperature, because in that order, when you increase the temperature, the spaces expand. And don't forget that from solid to liquid to gases, their spaces expand in that particular order. While if you reduce the temperature, the molecules have lesser kinetic energy. They don't collide with one another. They are more compressed. And moving from gas to liquid to solid, that's like the order of compression, of compactness. So I hope you have an idea about what I'm trying to like explain now. So changes between liquids and solids. So we have freezing. Freezing is when you are trying to convert from liquid to solid. That's freezing. For example, when you are trying to convert normal liquid water to ice block, that's freezing. And freezing always occurs as the freezing point. Now, a freezing point is the temperature where the liquid is being converted to what, to solid, or the solid is being converted to what, to liquid. It can either be that way depending on the direction of the energy. Either you're adding energy to it, you're increasing temperature, or you are taking energy from it, you are cooling it off. But then freezing is like you are taking the energy away from it. You are converting from liquid to solid. It's like you are taking the energy, you are using the temperature. Now, then melting. Now, melting is when you are converting what, solid to liquid. Solid to liquid. That's melting. And it actually involves you what? Adding, increasing temperature. You are adding its energy. And it usually occur at what? At melting point. Now, taking that, melting point is the same thing as what, as your freezing point. Okay, now changes between liquids. Now the one we just deal with is changes between what, solids and liquid. Now talking about changes between liquids and gases now. So you have vaporization. Now vaporization is when you are increasing the temperature of the substance, so that temperature of the liquid, so that the liquid now changes to what, gas, changes to vapor, which is one of the reasons why they call it vaporization. And usually occur at what, at the boiling point. Now while condensation is you taking it away from the gas. That's condensation. You are bringing it by, you are condensing it, you are making them more compact. And then the way you can do that is by removing heat from it, which is like you are reducing the temperature. So they tend to like have less kinetic energy, they have less collision, and then they tend to like clog up together. That's condensation. And this also occurs at what, at boiling point. And just take note that both of the process are almost the same, just like the only difference between them is like the direction of the energy. Are you taking energy away from the substance, or are you adding to it? So let's talk about, so the last one, which is what, changing between solids and gases. Now changing between solids and gases is what, is sublimation. It can also be is sublimation. Now what that means is like you are the process in which what, the solid is converted directly to gas. It does not have to go through the liquid and other kinds. It just goes directly from solid to gases. And then the other process is deposition, when you are changing directly from what, from gas to what, to solid. So all this has to do with what, the direction of what, the heat energy you are applying to actually cause the change. So that's all for state of matter and changing of state, and then vapor. So I'll see you guys in the next class.